Okay, so now that we have seen how to find out complementary function, we have seen how to find out particular integral. Let's solve a complete non-homogeneous linear differential equation. Okay, so let's solve two examples. The first being solve d square y by dx square plus dy by dx plus y is equal to 1 minus e power x whole square. Okay, so let me write in the form of differential operator, so I can write in this way, and this becomes and let me just simplify this. So this will become e power x whole square minus 2 e power x. Okay, so this will be 1 plus e power 2x minus 2 e power x. Okay, so now the first step is the complementary function. First step is complementary function, and that's why this, let me express this in this form. Okay, so for complementary function you have to just set take only the homogeneous part and set this is equal to 0. So auxiliary equation will be d square plus d plus 1 is equal to 0, or basically in the place of d you will substitute r plus 1 is equal to 0, and using the quadratic formula to finding out roots, minus b which is 1 plus or minus b square which is square minus 4 ac is 1 by 2a. So this comes out to be minus 1 plus or minus 1 minus 4 by 2. So this comes out to be minus half plus or minus 3i by 2 root 3i. Okay, because root minus 1 is written as I. So this is half, you can write in this way, minus 1 plus or minus I root 3 by 2. Okay, so you have two roots, therefore complex roots, so therefore the complementary function um, is basically e power this. If you write k plus or minus I omega, so e power kt, e power kx here, so e power minus half x into some constant, so c1 cos omega x plus c2 sin omega x. So omega, let me just substitute the values, e power minus half x c1 cos root 3 by 2x plus c2 sin root 3 by 2x 3 by 2x. Okay, so this is basically the complementary function. So now let's try to find out the particular integral. Let's try to find out particular integral. Okay, now particular integral, how will it come? The particular integral will be basically 1 by fd of basically the function given. Okay, and 1 by ft is nothing but your d square plus d plus 1 into 1 I can write e power 0 x. Okay, and the remaining I can just arrange in this form. Okay, so this is in the standard form. If you have a power x by 1 by fd of a power x, you can have e power ax by f of a. Okay, so we can have something like this, and if f of a comes out to be 0, then if f of a is 0, then we can have x into e power x by f dash a. Okay, so let's take separate by separate, each part separate. It's 2 I can take common, so e power x plus 1 by d square plus d plus 1 e power 2x. So this is like we have to substitute 1 at the place of e power 0, so it will be e power 0x by in the place of d1, so 0 square plus 0 plus 1 minus 2 e power x in the place of d1, so 1 square plus 1 plus 1 plus in the place of d 2, so 2 square plus 2 plus 1, so it will be 1 here, minus 2 e power x by 4 by 3 basically, plus 4 plus 2 6 plus 7 e power 2x. So what we got here is 1 minus 2 by 3 e power x plus e power 2x by 7. The complete solution is, therefore the complete solution for this problem is the y is equal to complementary function plus particular integral, and that comes out to be e power minus x by 2 was the complementary function, c1 cos root 3 by 2 x plus c2 sine root 3 by 2 x, now plus the particular real which we got 1 minus 2 by 3 e power x plus e power 2x by 7. So this is the complete solution. Okay, so let's solve another problem on this. So let's solve another problem. Solve the initial boundary value problem, where y dash double dash plus 4 y dash plus 4y is equal to 3 sin x plus 4 cos x, and what are the values given? The values are y of 0 is equal to 1, that is when x is equal to 0, y is 1, y dash 0 is equal to 0. So under these two boundary conditions we need to solve this problem. Okay, same thing. So first is to find complementary function. So complementary function, let me write in the standard form. So this is d square plus 4d plus 4 of y is equal to 0. This is the corresponding homogeneous equation of this. Right hand side, we are only just taking the left hand side, and the auxiliary equation is basically d square plus 4d plus 4 is equal to 0. If you put d r in place of d, it should be 4r plus 4 is equal to 0. So this I can straight away put in this form, r plus 2 whole square is equal to 0. So you have two equal roots which are minus 2. Now when you have equal roots, the complementary function looks like this. Let me write complementary function. It looks like this: c1h plus c2h. So c1h plus c2 and e power minus 2, basically rt, but here it's x only, because whatever the independent variable is there, that comes here. Okay, so this is about the complementary function. Now let's find out particular integral, because this is, to find particular integral you require some manipulation. I mean, you need to remember the formula. So particular integral is 1 by fd into x, which is nothing but 1 by d square plus 4d plus 4 into 3 sin x. Okay, let me separate it. So d square plus 4d plus 4 cos x. Okay, now what I am doing is I am putting d square as minus a square, which is minus 3 square or minus 9. Okay, so let me just put that first. This is minus 9 plus 4d plus 4 into 3 sin x. Okay, and similarly here also minus 9 plus 4d plus 4 cos x. Okay, so how does this uh, gets shaped out? I mean, d square, sorry about this, a is 1 here. This is the coefficient, this is not a, this is 1, and this is also 1. So d square is equal to a square, which is minus 1 whole square, which is minus 1. So it will be minus 1 here. Sorry about that, we have to substitute this. Okay, so this comes out to be 4d plus 3 into 3 sin x plus 4d plus 3 4 cos x. Now what we can do is, when we have something like this, you can't express in terms of d square, you have to just, you can multiply and divide by 4d minus 3, so that you can make so 4d minus 3 will be something like this by your so 4d plus 3 into 4d minus 3 will make me 16d square minus 9 into 3 sin x. Similarly here also, and now you can substitute in the place of put d square in the place of minus a square, which is 1 here. So if you substitute like that, you will get minus 1, so minus 16 minus 9 3 sin x, and this as minus 16 minus 9 4 cos x. So you will get minus 125 and minus 25, so minus 1 minus 1 by 25 you will get 3. And now this 4d minus 3 you can just take inside 4d minus 3, and let's see how you get it. Okay, so when I take 4d minus 3 inside, let me take out 3 also common, so minus 3 by 25 you have 4d minus 3 sin x, and you have uh, 4 by minus 4 by 25 4d minus 3 cos x. Okay, so let's simplify further. uh, d is basically like a differential operator, so you can write minus 3 by 25 4 differentiation of sin x, okay, minus 3 sin x. Similarly minus 4 by 25 4 into d of cos x, basically d by dx of cos x, it doesn't mean something magic. Okay, minus 3 by 25 4 sin x is cos x, and this is minus 3 sin x. Then you have minus 4 by 24, you have 4 cos x derivative minus sin x minus 3 cos x. So if you just simplify, what will you get? Okay, so this let me just recall 1 by 25 common, so you'll get minus 12 cos x plus 9 sin x plus 16 sin x plus 12 cos x. So cos x terms gets cancelled out, you will get 20. So basically you will get sin x. Okay, to be simple, you'll get sin x. Okay, this was about the now the complete solution is y is equal to complementary function plus particular integral, and that comes out to be c1x plus c2 e power minus 2x plus complementary functions. Now in order to find out the arbitrary constant c1 c2, they have given the condition. So y of 0 is 1. Okay, so let's substitute y of 0, how much you are getting. It's 0 is e power 0 plus sine 0, so you will get how much? c2, and c2 comes out to be 1, so c2 is 1. Now y dash of 0 is 0, so let's first derivate and find out y dash. That's, so that is nothing but c1x plus c2, chain rule now here, so minus 2x into minus 2 plus e power minus 2x, chain rule is c1, and sin x is cos x. Okay, now y dash of 0 will be c1 0 plus c2 e power 0 minus 2 plus e power 0 into c1 plus cos 0. So this will be minus 2 c2 plus c1, cos 0 is 1, and this value is given as 0. Okay, we got c2 0, so c2 0, c2 is 1, so minus 2 plus c1 plus 1 is equal to 0, so c1 will be plus 1. Okay, so now let's substitute back c1 and c2 together in the complete solution form to get the required solution for the given initial value problem. So x c2 is 1, so x plus 1 e power minus 2x plus sin x. Okay, so this is plus sin x, this is your required solution, the required complete solution for the differential equation. So let's solve one more example to get familiar with the entire procedure. So solve d minus 2 whole square is equal to 8 into e power 2x plus sine 2x plus x square. So this, after this we'll begin, we'll stop this topic because I think we have solved enough examples. So this is our last example in the topic. Okay, so first thing is to find complementary function. Now how do I find complementary function? To find complementary function, the auxiliary equation should be your d minus 2 whole square is 0. Basically putting r in terms of d is 0. So r is equal roots 2 and 2. So the complementary function is basically c1x plus c2 e power rx. So this is nothing but c1x plus c2 e power 2x. So this is your complementary function. Okay, now to find particular integral, how do I find particular integral? Okay, so particular integral, how do I find? Particular integral is nothing but 1 by f of d, 1 by f of d of x. Okay, so 8 e power 2x plus 8 sine 2x plus 8 x square by, this is, okay, d is d minus 2 whole square. Okay, so now how do I get, now let's separate individual terms. Okay, let's separate each of the terms. Let's see, is e power 2x into 8. So this will be basically 8 into, okay, and so if I substitute 2, the f of a will be 0. So I need to use and okay, so e power 2x, just do it in the rough. F dash f of 2 will be, now f of 2 will be 2 minus 2 whole square, it will be 0. Okay, now let's put f dash d will be 2d minus 2 into 1. Now here also f dash 2 will be 0. So again I have to use f double dash d, which is 2. Okay, so this will be 8x square into e power 2x by f double dash d 2. Okay, so this comes out to be 8x square e power 2x by f double dash 2 will be basically 2. Okay, so it will be 4x square e power 2x. Okay, that is the first term. Now second term is sine 2x by d minus 2 whole square. So this, let me just simplify. So this will be d square minus 4d plus 4 if I just expand. And now here I need to put d square as minus a square, which is 2 square minus 4. So let me put minus 4 minus 4d plus 4 sine 2x. So this will become minus 4d sine 2x. Well, 1 by d is basically integral sine 2x dx. 1 by d is just one of the property. 1 by d, we have seen this, 1 by dx is basically integral x dx. Okay, that's what the inverse operator means. So minus 8 by 4 sine the integration is cos 2x by the internal derivative. So this comes out to be plus cos 2x. Okay, and now the remaining term is d minus 2 whole square x square. Yeah, now here we have to apply rule number 3, which was basically you have x power m, and then so this was expanding this in a reverse way. So let's take 2 common here, so it will be 4. It will be I can write 1 minus d by 2 whole square, or d by, yeah, d by 2 whole square I can write. I mean, I can adjust the minus in this way I can write. So this entire thing, remember there's a 8 here, there's a 8 here, there's a 8 here, so 8 by 4. So this I can write, so this I can write 1 minus d by 2 whole power inverse x square. Okay, now I need to expand the series 1 minus d, sorry, whole power minus 2. So this is basically in a binomial sense I need to expand. So let me call 8 by 4 as 2. I mean 8 by 4 is 2 in fact. Okay, and now 1 minus d by 2 whole power minus 2. Let me expand this. So this comes out to be minus 2 d by 2 plus. So I am just expanding it by using binomial theorem. Well, I don't need higher terms here, because even if there are higher terms, the x square, because d involves basically the derivative of x. So if you have derivatives more than 2 times, then the third derivative of x square will be obviously 0. Okay, so now only 2 terms are necessary. So let's just simplify this. So 2, this comes out to be 1. After simplification, this comes out to be 1 plus d plus 3d square by 4 plus so on into x square. So this becomes basically 2 into h square. Okay, means it multiplies with 1, then with d it multiplies, you get 2h plus then 3 by 4 into 2 be the constant. So this value comes out to be 2h square plus 4h plus 3. Yeah, this value comes out to be 2h square plus 4h plus 3. Okay, so this is just based on substitution you will be getting it. Okay, so let me just put together. We know now the particular integral that comes out to be. So the total particular integral is, adding all the terms, it is 4h square e power minus 2h plus cos 2h plus 2h square plus 4h plus 3 is the particular integral. So the complete solution is y is equal to the complementary function plus the particular integral. So that we have already found out. So c1h plus c2, or c1 plus c2h, whatever way you want to consider, e power 2h plus these terms, the particular integral terms. So we have almost solved all the most of the examples using almost all the rules once. Okay, so this was how you solve a non homogeneous linear differential equation of higher order. Okay, with constant coefficients. That's what was the problem, and we have solved it. So now there is another method that is mentioned, and sometimes in the previous year's syllabus, and so that method is method of variation of parameters. So let's look at quickly the method of variation of parameters in order to find out the particular integral. Okay, so this is another method to find out particular integral. So this method is quite general, and it basically applies to equations of this form. So you have something like this, okay, where p, q, and x, capital X, are functions of small h. Then directly, like, it involves a lot of derivation, so we are not deriving. What I'm saying is the particular integral states this form: minus y1 y2 capital X by w dx. So let me define what is w after some time. So this is the form. Now what are y1, y2, and w? So where y1 and y2 are the solutions of the homogeneous part of this expression, whereas w is depth y1 y2 y1 dash y2 dash. Okay, and this is called Wronskian of y1 y2. So Wronskian was just a scientist name, so that's what it says. So basically w is a det of y1 y2 y dash y2. So this is like method of variation of parameters, just another method to find out particular integral, and this is quite general. I mean, it doesn't depend on the form of x. Like we have seen previously, so many rules. Like if x is e power ax, then you have one rule. X is sin ax plus b, or cos ax plus b, you have another rule. X, capital X is x power m, then we have another rule. But this is quite general. Okay, so it depends for any capital X. So let's solve one problem. Okay, to so that it helps us in understanding this method very well. Okay, so let's take this problem. Use method of parameters of method of variation of parameters basically to solve d square y by dx square plus 4y is equal to tan 2x. Okay, so let me put this in the standard form. This is d square plus 4y is equal to tan 2x. Okay, so now the complementary function will be d square plus 4 is equal to 0, or r square plus 4 is equal to 0. R is equal to plus or minus 2i. So when r is equal to plus or minus 2i, so keeping in this k plus I omega form, k is 0, omega is 2. So I can write e power, the complementary function is e power kx cos c1 cos e power kx c1 cos omega x plus c2 sin omega x. This was the complementary function when the roots are complex. Okay, so e power 0x into c1 cos 2x plus c2 sin 2x. So e power 0 is 1, so you'll get c1 cos 2x plus c2 sin 2x. So this is your complementary function. Now in order to, so this is standard what we have done. Now in order to find out particular integral, let's apply the method of variation of parameters. So now the particular integral will be, so second step is finding particular integral. Okay, so particular integral we have y1. Okay, now so the solution of the complementary function solution is important, because we have c1 cos 2x plus c2 sin 2x. So this is basically your y1 and this is your y2. So y1 and y2 are the solutions of, that's what we told you while telling about this method, that y1 and y2 are the solutions of y double dash plus p y dash plus q y is equal to 0. So y1 y2 I know. So y1 is cos 2x and y2 is sin 2x. So I can now and capital X is what? Capital X is tan 2x. That is the right hand side part. Okay, so let's find out the det first, w, which means y1 y2 y1 dash y2 dash. So this comes out to be cos 2x sin 2x, and cos 2x dash will be minus sin 2x into 2, and this will be cos 2x into 2. That, so this on simplification, let's simplify 2 cos square. So that is, you have a b c d, the net of that is ad minus bc, right? So here 2 cos square 2x minus sin 2x minus 2 sin 2x, right? So this becomes 2 cos square 2x plus sin square 2x, which is 1 by the trigonometry identity. Okay, so w comes out to be 2. So now the particular integral form, we have to just recall the formula, which is minus y1 integral y2 x w dx plus y2 integral y1 capital X w dx. Okay, w dx. So now you have to just substitute this. So y1 is basically cos 2x, y2 we got y2 is sin 2x, and capital X is basically your tan 2x, and w we got to be 2. So this is first integral. Now same thing, sin 2x, substituting each of the terms, y1 y2 w, Okay, now we have to think, okay, what are the uh, differentiation for sine 2x, tan 2x. Okay, so now we have to just evaluate the integral. Okay, so let me just write in this way: sine 2x tan 2x is basically sine 2x by sine 2x by cos 2x. So this becomes sine square 2x. So sine square 2x I am writing cos square 2x by cos 2x. 1 by cos 2x I am writing secant 2x minus cos 2x. Okay, so because now if I have separated, now I know integral individual integrals. Integral log integral secant x is secant x plus tan x. Integral cos 2x is basically sin x. So in that form I can just substitute now. So minus cos 2x, let me take out 2 common. This I can write integral secant 2x dx minus integral cos 2x dx. Well, similarly here, this becomes quite simple here, because tan 2x is sin 2x by cos 2x, so it becomes sin 2x dx. Okay, so now integral secant x is basically log secant x plus tan x. Okay, so this is one which you should know. So this is half cos 2x. Okay, so integral secant x is secant 2x plus tan 2x by the internal derivative, which is 4. This is log, yeah, log of secant x is going by this, and integral cos 2x is sin 2x by 2. Okay, and now this part will be half sin 2x, and now integral of sin 2x is cos 2x by 2. Okay, so now on simplification, this comes out to be minus 1 by 4. I mean, there has to be 2 here, not 4. Has to be 2 here. Minus 1 by 4. Minus 1 by 4. You can write cos 2x. Okay, and this will be log secant 2x plus tan 2x minus sin 2x, and this will be minus 1 by 4 sin 2x cos 2x. Okay, I think this term combined with this will get cancelled with this, so you will just remain with minus 1 by 4x cos 2x log secant 2x plus tan 2x is the partial integral. So the complete solution, so see, it is very simple now. I mean, you need not use all the inverse differential approach, because then you have to struggle. This is just find out w based on, first you have to get the complementary solution. Once you get the complementary, find out y1 y2, I mean, and then find out w, and then just use this expression. So it all boils down to integration. Okay, so the complete solution is the complementary function plus the partial integral. So that comes out to be c1 cos 2x plus c2 sin 2x, and then this one minus 1 by 4 cos 2x log secant 2x plus tan 2x. Okay, so this comes out to be complementary function plus partial integral. So this is the solution by method of variation of parameters. This is how it looks. Okay, so we have seen two methods for particular function finding, particular solution or particular integral finding. One was the inverse differential operator, that we have seen various rules. First we have defined what is inverse differential operator, and then the properties of inverse differential operator, and then various rules for capital X. If capital X is e power x, then what to do? If sin ax plus b, then what to do? Cos ax plus b, then what to do? If it is x power m, then what to do? And then the partial fraction method. And then we have seen the complete solution, complementary function, particular integral. And then now in this section we have seen, in this section in the last we have seen other method of finding particular integral which is more general, the method of variation of parameters. So this also can be used sometimes. Only thing is it is cumbersome when if it is more than order 2, then finding w and stuff like that, it will be difficult. Okay, so this is all about all about linear differential equations, but with constant coefficients, and the general case, homogeneous or non-homogeneous. If it is homogeneous, there will not be particular integral. If it is a non-homogeneous, there will be particular integral also.